Good evening, everyone, and thank you so much for joining us. I can see quite a few of you who have started trickling in. Once again, welcome and thank you so much for joining us on this wonderful Monday evening. In the chat window, very quickly, if you could let us know which city you're dialing in from, it really gives us a broader understanding of where our audiences are coming in from and also helps us get to know you better. So, to all 70 plus of you who have joined in, very quickly in the chat window, if you could let us know which city you're dialing in from. So we have people from Noida, from Hyderabad, anyone else? We have people from Bangalore, from Kurukshetra, Bhopal. I see all of you from the length and breadth of India. Oh, some people from Lahore and Karachi as well. Welcome once again, all of you. We have a very, very exciting lineup for you today. Like I said, it's a very exciting masterclass, which is brought to you by Boston University's Graduate School of Arts and Sciences. And welcome everyone to this very exciting masterclass. Today, we are going to be talking about mitigating biases and vulnerabilities in large-scale AI models. As I mentioned, the masterclass is brought to you by Boston University's Graduate School of Arts and Sciences, located in one of the most renowned educational cities in the world. No brownie points for guessing where that is because the name itself should be an indicator of that. It is one of the largest schools within Boston University, and it offers an expansive curriculum that nurtures intellectual curiosity, encourages interdisciplinary collaboration, and challenges its students to think beyond traditional boundaries. They have a robust alumni network of over 300,000 professionals living and leading in more than 180 countries, and it has a high reputation globally for its employment ranking. So every one of you, very, very exciting class. Like I said, we're going to be talking about AI. The focus is going to be on understanding biases in AI, techniques for bias mitigation, ethical AI development, and future trends in AI. Of course, to all those of you who have tuned in, AI is the buzzword today. So without further ado, I'm going to do a quick round of introductions to our esteemed panel, which is present here today, starting with myself. My name is Sabahat Herzog. I'm the Associate Director at Seed Global Education. We're a UK headquartered company which facilitates interactions between top global universities, like the one that we have with us here today, and prospective students like yourself, giving you all a chance to meet with the faculty, understand the kind of subjects, understand the kind of flavor of what's being taught on campuses, and of course, helping you in making more informed choices about your career. Joining me on the panel today is Professor Plummer. Thank you so much, Professor, for taking out time from your busy schedule and joining us. He's an assistant professor in the Department of Computer Science at Boston University, where he has also previously worked as a postdoctoral associate and research assistant professor. His research interests fall within the umbrella of artificial intelligence, with a focus on visual recognition, scene understanding, interpretable machine learning, and understanding the relationship between vision and language. Along with him, we also have Mark Khan. Thank you so much, Mark, for joining us. Mark
My
is
pleasure.
the Thank you. Mark is the director of Masters Marketing and Enrollment at Boston University's Graduate School of Arts and Sciences, a role that he's been in since 2002. With nearly 3 years of experience, Mark oversees marketing strategies, enrollment initiatives, and of course, helping student engagement. If you are looking to get into Boston University, Mark is your go-to person. So that's who you should be talking to. Well, great. I see we are close to 160, 170 odd people. While we wait for a few more to trickle in, I'm going to quickly run the first poll question for today to get an understanding of where do y'all stand with your understanding about AI. So on the screen in front of you, according to you, what do you think will be the most impactful future trend in artificial intelligence? Is it going to be advances in generative AI, that is creative content and innovation? Is it going to be AI in healthcare, personalized medicine, diagnostics? Is it going to be AI autonomous systems, that is self-driving vehicles, drones, AI for climate change, resource management, sustainability, or ethical AI and regulations, which is transparency, fairness, and governance? I know this is a very, very deep question. So very quickly, on the screen in front of you, if all of you could just go and cast your votes, I'm going to keep the poll running for a few more seconds before we sort of hand over to Professor and get to learn a lot more about this topic today. So I'm going to wait for a few more of you to sort of come and cast your votes. With that, I'm going to end the poll question and share the results, which are on the screen for all of us to see. So 38% of you feel it's advances in generative AI. Some of you feel it's autonomous systems, followed by AI in healthcare, and the others lagging behind. So thank you so much, all of you who have participated in the poll question. With that, I hand over to Professor Plummer for his presentation. Thank you so much.
All right. Well, thanks, Course, for that great introduction. As you said, my name is Brian Plummer. I'm an assistant professor at BU. I've actually been at BU since 2018. And as you mentioned, started as a postdoc, and now I'm basically an assistant professor. And so at BU, I'm a member of the Image and Video Computing group. And this is a relatively large group at BU, so there's a lot of students in it. And just to give at least some idea of the scale, so this is actually an old photo. So at this point, our group is even larger, but this is a photo of people in the Artificial Research Initiative within Boston University. And we kind of see here, it's like a big group. We have a lot of people in there who can do a lot of basically different kinds of research as a result. And just to give a high-level overview of at least some of the projects. So this is, of course, going to be a very small slice of the different kinds of research that goes on at BU. And so one of the big topics over here we can kind of see is this kind of pose estimation. So a lot of work on this mostly focuses on humans, but at BU, a lot of the research here also focuses on not only humans, but also other animals. So this kind of general idea. And so in pose estimation, this is just trying to get the orientation. And so each of these little dots on the animals, this is actually meant to be this specific position, right? So some of these dots over here would be supposed to be on the head. This yellow dot over here is supposed to be actually specifically on the tail of the animal. And so this kind of gives you this idea of like exactly what, how the animal's oriented. And sometimes some of these locations, we can't actually see them. Other things here, like, as we kind of just mentioned, there's a lot of buzz around generative models. And that actually is both exciting because you can actually use these models to do a lot of good things, but there's also a bit of danger that comes up along with this because a lot of these generative models can be used for nefarious means. So this kind of brings up at least some elements where we might want to defend against these generative models used for bad means. And one way we'd be able to do that is just by simply being able to detect it. And so this was actually a work where we're actually trying to detect, whether or not a piece of text was generated. And this is actually trying to get a little bit of a fine-grained distinction, right? Because it's actually seeing if the text itself is generated at a sentence level. And then, of course, we have some other, what I would consider like more classic problems where we're trying to understand the data a little bit better. And one of the big challenges here is whenever we have videos, whether being able to understand longer videos. So in this case, when we're talking about long videos, even a 3-minute long video at this point is considered to be a long one to be able to understand the content of it. So often what you do if you have an even longer one, you actually chop it up into pieces to try to understand each individual piece. And so this kind of gives you at least a little bit of an idea of at least one of the problems we would want to work on is to be able to understand these long videos. If we want to be able to, let's say, have a robot going around a room and understanding what's going on there, we need to be able to understand basically streams of videos, which might be relatively long. There's also other problems here where we basically try to improve the capabilities of a model. And one of the things that we found was that if you just ask one of these large language models to be able to answer questions, sometimes it might not get it right. But what we ended up finding is that if we actually took two language models and had them actually debate an answer, that we can actually do a little bit better job of actually arriving at the correct answer if it was asked a question. So this was actually something where we basically let the language models talk to each other, and it actually allows them to get a better response. Kind of following up on this kind of generative modeling, there's a lot of tasks here that where we might not want to change the entire image, where we might only want to change some aspect of it. So this is showing an example of a task called virtual try-on, where the goal is to, let's say, take some user photo, and then let's say a piece of clothing that the person might want to wear, and then try to generate an image with that person wearing a piece of clothes, or that specific piece of clothing, right? So this is like, an e-commerce website where they want to try to sell some clothing, and this gives them a better idea of what this might look like, and hopefully that results in someone purchasing the item. And of course, we might not want to just edit images of clothing, right? There's also, kind of more general changes that you might end up wanting to take. And so this is at least another task that, another kind of set of tasks that students at BU have studied. And, as we kind of also mentioned, there's Boston University has a pretty large medical school. And so there's a lot of work here on medical and biological research. And so some of our students actually focus mostly on this one. So this is an example of a biological task where we assume that the image, or at least the images themselves that we have, they might have like been imaged with different microscopes or for different purposes. So they might actually capture different kinds of information. And here's basically a kind of line of research where we're trying to be robust to whatever it captured. And this is mostly comes up, like I said, in medical and biological settings, also sometimes with satellites, right? Different satellites might have different sets of sensors, and we might want to train a single model that's able to reason about models, regardless of like whatever kind of input data it was given, right? So this kind of gives a little bit of a flavor. If I was just going over a high-level overview, we'd probably spend the entire time just talking about that. So but at least this hopefully gives you at least some elements of what what you'd see. From here, I'm actually going to go over some other specific projects in a little bit more detail. And to preface this, I'm sure that many of you have heard about generative models, and these models we can kind of see here. This is what it's plotting is, of course, on the x-axis is the years, and on the y-axis here, we'll see is the number of parameters, right? And in here, this is the, model weights, the things that's actually being used to, let's say, transfer data, right? So at a high level, any kind of machine learning problem is just trying to learn a function that'll take it from one data type into another, right? And if we're trying to do something as simple as like image classification, this is basically taking an image, that's our data type as input, and we're learning a function that'll transfer it to a set of classification labels, right? So if you have if you're running this on the ImageNet data set, there's usually 1,000 labels there. And so it's just going from an image input to that 1,000 label space. So in here, once we get into billions of parameters, right? So something like ChatGPT, and here even ChatGPT is a relatively small model, right? We're kind of see in this like, GPT-3 is like a earlier version of ChatGPT. And so once we get into even the size here, it's actually hard to fit these models into memory. And in particular, we're talking about GPU memories, which is where a lot of these models are actually going to operate. And we kind of see here that the size of these, if it's hard to fit it into a single GPU at the small range, once we get into, GPT-5, or at least what people might think GPT-5 will end up having in it, you end up needing many GPUs just to be able to load the model into memory, let alone to be able to perform any kind of operations on it. And so this, as we've kind of heard, these kind of models have improved the performance of a lot of different elements. But at the same time, they bring up a lot of different issues. And in particular here, we want to think a little bit more about the responsible use of all these large models. So at a high level, what we end up doing is we end up collecting some large-scale pre-training data set. And so this is often just going to be web scraped data. And this is going to be very important because there's going to be some properties of web scraped data that we might want to be able to understand a little bit better. And after we collect this pre-training data set, these are usually not going to be labeled data, or at least they're going to have only very loose labels associated with them. So we end up having to come up with some kind of like self-supervised approach. And this kind of gets into this model pre-training phase, where we basically just try to learn something good from these large-scale data sets. But of course, these aren't going to be aligned with any kind of downstream task. So at that point, what we would want to do is we'd want to do some kind of task fine-tuning and align this with some goal task at the end, right? So this is showing an example with MS Coco. This might try to localize objects and images would be like an example of a task, or like even segment them out to be able to make pixel level predictions. So any kind of machine learning application, this is going to be like the general process that we end up using for it. We use this, large scale pre-training data set to get some good initialization, to get an understanding of what the kinds of, let's say, vision or language inputs that we might want to represent. And then we, align it to some kind of downstream application. So when we were thinking about this process, we wanted to ask these kind of two questions, or at least I'm going to go over these kind of two questions in this work. The first one here is to try to understand a little bit about how robust these large models are, right? So we spent a long time doing pre-training on a data set called ImageNet, as opposed to these large-scale web data. So we want to understand a little bit more about what ramifications happened or what issues happened as a result of doing this change. And then at the end here, we'll talk a little bit about how we might be able to reduce biases in these data sets. And this is mostly thinking about how we might want to train using these kind of downstream tasks. So to get into this kind of first topic here, one of the areas that we focus on a lot at BU is this idea of dealing with domain shifts. And so this task here of domain generalization, what it kind of refers to is that it assumes that let's say we've been training on some data sets, right? And here we're kind of assuming that we have multiple sources. So let's say, we went out and we were trying to, let's say, have an autonomous vehicle drive through a city, and we could think about each city as being a different domain, right? So if we end up, trying to train a model on 3 cities, and then when we actually deployed the model, it went to a 4th city, we wouldn't have necessarily seen that 4th city, and there might be some unique characteristics of that city. And as a result, we think about this as like a shift in the distribution of the data, right? And so this domain generalization task is thinking about these shifts in the distribution of the data where we don't know, or we don't have an example of what those shifts are. And one of the things that we've kind of seen here is that these large scale models have often been used for, or like have been at least used more and more now as a way of initializing at least the models that we were going to be fine tuning from. And they've been reporting some really good performance gains out of it. So to kind of make sure we're kind of on the same page, right? So what we're kind of considering here is we end up having this large scale pre-training data set that we end up doing our fine tuning on. And then, after we did our fine tuning, we evaluated on these OODs. So these are out of distribution samples, right? So this is the basic process for which we perform this kind of domain generalization task, or at least we're going to evaluate it. And this is going to seem a little bit obvious, but this large-scale pre-training data set and ImageNet are not the same data set, right? So this is, not a surprising comment, but it is very important here because most of the domain generalization benchmarks were developed assuming that in this pre-training phase, we were using the ImageNet data set and not some web scrape data. And this, we had this idea that this might affect how well, or at least there's some possibility it might affect how well we can actually evaluate this domain generalization task, right? So from here, we end up doing a little bit of a study, right? And on the x-axis of this plot here is going to be some alignment scores. So this is how well aligned a specific data sample might be with the pre-trained model. So this is like the model before it made any changes to it, just like the initial alignment. So we can kind of think about this as like how well the model can already represent that sample. And on the y-axis here, we can see accuracy. And so at a high level, it's maybe unsurprising when we look at this and we say like, oh, well, accuracy is improving as the alignment's going up higher, right? This kind of, saying like, well, if the model can already represent this data sample, well, we're probably going to get a good answer to it, right? Or at least have a good prediction on it. And what our thought here was like, if there was some issue with the data set, maybe at these very high levels of alignment score, we might end up seeing at least even some potential for train test contamination. So in this case, what it means is that during our, let's say, training or pre-training phase in this case, we might have seen a sample that looks very similar, or at least, or especially might be exactly the same as a sample that we see at test time. And in fact, this is actually something that we did actually find, right? So if we look at these pairs of images on the left here is a image from one of the evaluation sets of these data sets, and we kind of see here. And on the right here is the nearest neighbor retrieval from this Lion data set, which is, of course, one of these large pre-training data sets. And we can kind of see here for these images, like they are not exactly the same. There's going to be some slight shifts in them, but I think we kind of agree here that these are largely the same image. And this kind of shows that there's a little bit of at least train test contamination going on between these data sets. So this is not necessarily really evaluating domain generalization at this point. It's kind of having some mix of maybe some out of distribution samples and some in distribution samples. And because of that, we wanted to have a better understanding of how this shift might occur, right? Or like what's the difference between these two buckets of samples. So if we just go through and split the data, so we can kind of decided here is going to be our threshold, and we say like, well, at anything on the right side, we're going to consider as in pre-training. So you either had a sample that was very similar, or in some cases exactly the same as the samples that we saw during the pre-training phase. And on the left side here, we're going to consider these as out of pre-training samples that were not well aligned to during pre-training. That doesn't mean that after we train on the target task, maybe we would actually get the alignment a little bit better. But this is going to be one of the things that we're going to end up having to evaluate. So to kind of look at some of the results here, so this is showing a recent paper, right? So it was a paper that was just published over the summer. And we kind of split, we can see here the two different in pre-training and out of pre-training splits. And we also have one metric here that's going to evaluate on all the samples. So this is like more like what would be reported in prior work. And then the to show one of the issues, so this is a paper that was published, 2 years ago. So it's going to be a much older paper. So you can imagine here that 2 years of research have gone into studying this problem, and better methods have come up. And what we kind of see here is that on the out of pre-training data sets, it is the more recent method is doing better, but this gap has shrunk considerably. Um, and we can kind of see that most of the gain here is actually coming on the in pre-training data sets. So we're kind of like overestimating how well we're actually going to be generalizing to these out of pre-training samples. Um, and this kind of gets us the simple conclusion here that while we are doing pretty well on this in pre-training data, all these out of pre-training samples, we're actually not aligning to them well. We're actually still doing pretty poorly on getting these samples correct. So this kind of highlights the kind of need for having essentially a new way to evaluate these models so we can actually better represent the actual target task, this kind of goal of trying to generalize the samples. So this does suggest that like these large models are potentially still useful for evaluating this, but a little bit more care needs to be taken so that we can make sure that we're evaluating on the right kind of thing. Now, I guess from here, I'm going to think a little bit about the some of the other ramifications that come from dealing with web scrape data. And in particular here, if we think about web data, there's going to be two components here that we're often going to be looking at. One of them is that a lot of web scale data might end up having some text. So if we think about like a meme online, this is going to have an image and a little bit of text written on it, as well as logos. So some companies might upload some images and they might put one of their logos on that image. And we wanted to understand a little bit about what issues might come up due to looking at this web scale data. And in particular, this is going to kind of show a good example here. So this is an image of New York City. And we kind of see here in the middle, this is the Empire State Building. So like an iconic building in New York City. And we end up going through and just writing the words Boston on it, right? Because we're at Boston University. So we see what would happen if we just decided to claim this as ours. And then we went to one of these large models and started asking it questions. So we'd give them this image and we'd ask it, well, what is the city? And it was like, well, the city is Boston. And it's like, well, we kind of know it's clearly not. And they're like, okay, we're like, well, maybe we can get the model to figure out that this answer was wrong. So then we'd ask it like, well, what's that building in the middle? And then it correctly identified it as the Empire State Building. But then when we asked it, followed up, asked it where it was located, it was like, well, that's in Boston. So this kind of shows that kind of even when we're trying to get some semblance of what the task is, it's still not able to get the answer correct. And we even asked it explicitly like to ignore the text in the picture and ask it what the city is. And it was still saying that this is in Boston, right? So this kind of shows some issue that because we end up these models are trained with a little bit of text on there. It did learn how to recognize what that text was, but now it's relying on that signal. And then you could end up introducing this kind of vulnerability. Now, of course, one of the big issues with this is that maybe like we would have to end up deciding what to write on an image. But then we thought, well, if these models are really good at generating samples and generating information, maybe we could just use one of these vision language models themselves to actually give us recommendations of what to write. And so this kind of shows an example, right? We end up having an image, and then we end up asking a model to recommend an attack. So, some kind of text to be able to write on this image. And then end up giving us a sample like, oh, well, this is the class you should write. And here is going to be some kind of description of it. And Unfortunately, this was pretty successful. We asked these models what we could do to fool themselves, and they gave us an answer. So we can see here by just writing the class on the image, could end up getting, between 30 and almost 40% of an accuracy drop on a lot of these models. If we end up, and the description, we also found that the descriptions themselves are useful. So we kind of see here the difference between adding some random description or adding the description related to the class. And we kind of think about these models as ordered from the strongest model to the weakest. And on the strongest models here, this kind of class descriptions are actually more effective. So it's actually taken into that text into account even more than some of the weaker models. And of course, as we kind of alluded to, text isn't the only thing here that introduced the kind of vulnerability. If we were thinking about, so in this case, to illustrate, we would be thinking about this task of hateful meme detection. So this is showing an image with a bunch of text. And the idea here is to try to get a model to be able to predict whether or not this is a hateful or benign uh, meme, right? And so this is like trying to help. This is actually a data set collected by Meta and released to try to, help them with their content moderation, basically. And what we end up finding here is that if we end up adding some logos to these images, this doesn't necessarily change any of the content of the image, but it does at least affect the prediction, right? So even though that this is still going to be hateful meme, just by adding this logo, it suddenly thinks this is harmless, right? And so this is some issues that we end up observing here, that a lot of these big models are affected by these kind of spurious logos. And so we end up going through and analyzing this, figuring out, for any kind of content moderation or a bunch of different tasks, what are going to be the logos that are aligned with, some potentially negative effects. So this is a way that you can end up changing what these large models understand just by adding some logos to the image. And some of these, like, they really don't make any sense. You know, uh, um, they're just, some kind of, something in the pre-training data ended up introducing this, or maybe it was the fact that the pre-training data didn't necessarily take these logos into account, so then ended up learning some random information on it. But this whole line of work is to try to highlight there's going to be some issues here whenever you add these kind of logos to it. Now, of course, there are some ways of addressing this. And I guess in the interest of time, I won't necessarily go over it so much, but you can do things like randomly crop the image that can actually help improve performance a little bit. And so for the last couple minutes here, I'm just going to go really quickly over this idea of reducing bias. So just as, and on maybe better notes, we're going to talk about here a little bit of how you can actually use these large models to help reduce bias. And so the idea here is that let's say we have some task, right, where we're trying to, let's say, see if an image of a person is either smiling or frowning. And we can kind of see here that there's a split in terms of the gender disparity, right? So most of the females are going to be frowning and most of the males are going to be smiling in this data set. And so we still want to be able to train a model that performs well on this. And so despite the fact that we end up having this data imbalance, we want to learn a model that's going to be fair across both these groups. And one way we could do this, of course, is to try to generate some sample images to balance these data sets using some kind of generative model. And so prior work would either try to balance the data set or add a balanced synthetic data set. Both of them are aimed at trying to reduce the at least gender bias in these samples. But what we end up finding is that after training on these models, they end up looking all over the images rather than looking at the person, or at least focusing on the person, to try to make their predictions. And this got this idea of that maybe rather than aligning to whether or not someone's smiling or not, it ended up aligning to whether or not a sample was real or synthetic, because we end up having a very high bias here. Whenever, like, most of the female samples in this example are synthetic samples, and if we can end up just learning how to identify real versus synthetic, we can actually get the answer right most of the time due to how these data sets were constructed. So to address this, we actually end up splitting the data. So our goal here is to first use this balanced synthetic data to learn some kind of good feature distribution. And then in the second stage, since the synthetic data doesn't align well to the distribution of the data of our real data, in our second stage here, we actually do this alignment using some bias mitigation techniques to try to align our good unbiased features to the target distribution. And as a result, we kind of see here in this line, as we increase these bias rates, or at least overall these bias rates, we can actually see that this kind of approach does better than all the prior work. So it kind of shows how we were kind of very successful in this task. And of course, with these feature distributions, we kind of see here that, our model was actually looking at the right locations in these images when trying to make their predictions. And with that, we came to the end of my presentation. Of course, I highlighted a bunch of the students' work here, so we're kind of course, say thanks to them. And I guess we'll ask any questions here.
Thank you. Thank you so much, Professor. That was very, very insightful. I'm sure you can see the number of questions that have sort of poured in right after your presentation should be a good indicator of how exciting and insightful this was. So before I let you go, I'm going to take on a few questions and I'm going to club them together so it's easier for us to sort of tackle them. The first question that I'm going to take up is around AI in healthcare. So how can one ensure that the AI diagnoses are accurate and trustworthy, especially in critical cases in AI? That's a big question which has sort of come in today's masterclass.
Yeah, so this is actually a really important question. And in the end, this is actually one of the, like, every diagnostic test out there is going to have some inaccuracies to it, right? This is kind of the nature of these models. Our hope here is to be able to train AI models that are, at least more accurate than people are. But that still doesn't necessarily solve the problem entirely. So in the end, I would actually think about these AI models as not necessarily replacing people, especially not in the short term, but actually just using it as essentially another sample, right? So at a high level, like, if we think about how we would want to do this, there is at least a whole lot of work on actually how you can actually integrate AI models with healthcare professionals to get better outcomes. And there's, certain ways that you're going to end up having to integrate it, right? So this is going to be like a very careful step. And then the other thing, of course, is just like more general issues, which is like usually whenever you're trying to diagnose something, you're often not looking at one test, you're looking at a suite of tests and you're looking for essentially corroboration between all of them.
Right.
So this is a big issue. But there's not an easy solution to it, unfortunately.
Yeah, I'm sure as the AI sort of learns more and gets to know a little bit more, we would come to that sort of space where it can solve those issues. Great. The next big question, which quite a few students have asked, of course, is around AI's ethical balance. So there is a question from Sanya who wants to know that companies like Google, with Gemini coming in, have put in a lot of emphasis on ethical AI. How can organizations sort of embed ethical practices into their development process? And also, there are a lot of questions which are being raised on the ethical implications in AI.
Yeah, so this is a multifaceted problem, right? And there's going to be a lot of different ways you can think about this one, right? So to be honest, like it does seem like the companies themselves, of course, can try to address this by actually having teams looking at the effects of these models, especially when, um, if they're going to go, let's say, go out and deploy a model that actually that other people can use. So like something like, Gemini, you could imagine here that all the people who are going to use this model, they're going to have to get a subscription. You're going to have to know what the companies are. And then you're also going to want to know what the kind of social issues are there. So part of this will be that you should actually have a group in-house to study this problem, right? And there, of course, can be ethical issues that can come up within the models themselves, and then for the use of the models. And at least within the model themselves, that's something that's easier for the company to study themselves. In terms of the use of the model, it's hard for the company themselves to do much about that. That does seem like it's going to be a problem. Like part of it could be that they're going to restrict the usage of this, but part of this probably also have to be external factors, right? Like societal factors, government issues. They'll probably have to get involved in that kind of use as well. Yeah.
Great, thank you. One recurring question, and I'm sure you get asked this a lot, and I know a lot of students keep asking about this, is with AI coming in case no matter which field they are working in, will AI sort of take over people's jobs?
Hmm. Yeah. I'm sure that there's going to be, like with any technology, any kind of automation, there's going to be probably some jobs that either leave, or at least uh, there's going to be fewer opportunities for it, right? Because after all, like
Right.
um, one of the big challenges, of course, now is that since these models are so effective, a lot of companies might want their employees to use, let's say, like generative AI, right? Like if you're trying to write a document, they might want to help you to use it to help you, edit your grammar or make sure it's clear or any of these kind of things. So it is really important to I learn how to use it properly and, not result in more issues. But they kind of want you to do that because it's going to help make you more productive. And if you're more productive, that might be that there's going to be fewer jobs out there for it. But at the same point, like there are going to be, um, like I think of this more of like a job shifting as opposed to
Hmm.
like jobs being eliminating, because like as those jobs, let's say get taken up, there's then other jobs that become available, right? Because like if we get, let's say autonomous vehicles out there, there's of course going to need to be a lot of work on how you'd actually put it together and understand it and improve it, and there's going to be a lot more efforts in that space. um,
Right.
um, so, but it is a big societal issue, and
True.
like with any of these, there's has to be concerted efforts to make sure that there's at least as
Thank you.
little pain as possible. Yeah.
Thank you. My last question to you before I let you go, Professor, is while we spoke about which jobs will sort of become redundant, the other side of the coin, so to speak, is what are some of the careers which are going to be in high demand with AI, which will sort of help students, especially those prospects who are now looking at study abroad as an option? What are the kind of career outcomes that they can expect if they were to, let's say, take on one of these programs?
Oh man, so this one's gonna be like I always want to put the caveat here is that this is hard to predict, right? So like even my own job, right? Like where we're trying to do development on machine learning.
Yes.
There's also AI models that try to help make that faster and more effective, right? So we're also like optimizing away our own jobs to some degree. Um, so there's going to be some challenges there. But that said, like a lot of these skilled jobs, like I guess the kind of classic, like looking at like, engineering and medicine and all these ones, like especially the short term, it doesn't seem like these can go away, right? Because even if these AI models help a little bit, there was already a shortage in these areas anyhow, right? So we end up needing a lot more folks, especially in the US, who have these kind of skills. um, and then this and then because of that, even if like, some of those go away, that there would still be some pretty good prospects. And a lot of these skill jobs, it'll take a long time for the AI models to
Mhm.
become effective enough um, to be replacements as opposed to helpers, right? Um, but it's really hard to predict, right? Because
Predicted.
like if we went back like 5 years ago, I would not have guessed that we'd be in our position today, right? Because the models just changed so rapidly over that time, that yeah,
Yeah.
it's really hard to guess.
Thank you. Thank you so much, Professor, for your time and for answering those questions as well. With that, I know we are on a time check here. I would now like to invite Mark to speak to us more in detail about the university programs, scholarships, funding, and opportunities for the students which are available.
Thank you. And Brian, I know you have a flight to catch. You are more than welcome to depart. Thank you so
Thank
much.
you.
Good seeing
Thank you so
you.
much, Professor.
So let me share my screen. We are. So Boston University is one of the larger schools in the Boston area. And as you've heard from Professor Plummer, one of the things that really sets us apart is the level of collaboration that happens in Boston. And I'm glad that he mentioned the lab at MIT that he was collaborating with as well, because we are ultimately one of the largest educational hubs in the US. BU specifically is home to over 18,000 graduate students and over 37,000 students overall. So it is quite a large group of educators. We also are a tier one research institution. We're R1 rated, and our faculty are amongst some of the world's best and most renowned. So that is sort of the expectation that you're going to have if you are a BU student of who's going to be in the classroom with you. And also, we're drawing students from all over the world. So some of the resources that I like to point out. Your career development is going to be very important to us. The Center for Career Development has a lot of wonderful opportunities for you to tap into, one-on-one advising, global searches. We're not just limiting your search to the US. We also do have many ties abroad as well. So we want to make sure that our students land very well. Depending on your interest, depending on the groups that you might have an interest in studying with and under, there are many labs and things for you to take advantage of, and we'll talk a little bit more about that. But this photo is actually just one of downtown Boston, and you can see it's a thriving metropolis. It is on the smaller side, though, as major cities go. I am from New York. I've had the pleasure of visiting many of the larger cities in India. Boston is more of a microcosm of that. It's a smaller hub, but the programs that we offer are mostly STEM designated in the field that you're going to be looking at. So there are 40 different master's programs, 30 different PhD programs. We also do have an engineering school that's quite competitive and quite popular as well. So these may be some of the things that you might be interested in. But what I will say is there's a Center for Data Science as well at Boston University that pulls together many of the departments that are spread amongst our 17 different colleges. So what you will find is that students at our business school, for instance, will collaborate with students from Metropolitan College as well as with the students that are at GRS, the Graduate School of Arts and Sciences. So there is a lot of collaboration that's happening even internally. And then in terms of the things that you're probably most concerned about, scholarships, we do have very generous scholarship opportunities. We have SEED scholarships specifically for students who are participating through SEED, but also our scholarships range up to 50%. So 50% tuition scholarships are awarded. They are quite competitive. However, they are readily available, and we definitely identify talented students in our pool and we'll offer those to them. The priority deadline is January 15th. Our final deadline is typically March 15th. Space available basis, any students that apply after those deadlines, or rather after the final deadline, if there's space available in a program that you're interested in, we'll let you know, and then we will evaluate your application, pass it off to the department. But tying back to the facilities that you're going to have at your fingertips, because we are a larger institution, there's a lot of research that's happening right here at BU. So over $500 million was spent in total research awards in 2024. There are over 200 companies that are actively developing and selling products that are based on BU discoveries. There are 21 interdisciplinary research opportunities, centers, and institutes, as well as over 1,500 active research labs. So when students look at the opportunities and they say, well, how hard is it to get a lab position? It is competitive. You know, the faculty do have their pick of many brilliant minds. However, with 1,500 operating research labs at the institution, chances are that there are spots that are going to be readily available, particularly for master's students. And in terms of the facilities, there is the EPIC Center, our Engineering Product Innovation Center with over 15,000 square feet. There's a 2,500 square foot robotics laboratory with space for testing, autonomous aerial and ground vehicles. There's also a lot going on in the computing and data science realm as well. So you have access to a LEED Platinum Center building that houses our computer science department, our data science folks, as well as our statistical practice program as well. So there's a lot going on. There's a lot of amazing things that you can do on our campus. But the point is, if you don't apply, you'll never find out whether or not A, we would like to have you in our cohort, and B, if you're going to receive a scholarship. So what I will say is feel encouraged to apply, investigate, look at some of the opportunities that are available. Brian's a fantastic professor, but also very indicative of what you'll find in the department. Faculty are very hands-on. They want you to learn. They want you to engage. They want you to dig deeper than just what you're going to get from a textbook or from a library card. So making sure that you tap into those resources will definitely help with your BU experience. So with that, I will thank you for your attention. Thank you for um, being here and for paying attention to Brian's lecture. And yeah, I'll hand it back over to Sabahat.
Thank you. Thank you so much, Mark. That was very, very helpful. Quite a few students in the chat window. Mark, if you could stop sharing your screen, please.
Sure.
Yeah, great. So quite a few of you did ask about collaborations and scholarships. So Mark has just sort of answered that question for you. And I have also put the link to the Boston Scholarship with Seed Global Education in the chat window. So please feel free to have a look at it and explore, and please do apply. And we shall look forward to hearing from you. Another question which I am going to take, there are quite a few, but the first one that I'm going to go with, Mark, is how can they apply or get an application fee waiver?
Yeah, so we actually have an application fee waiver link that we'll send out to you guys. If you just take a screenshot of the email that you got to confirm that you participated in this event, you can add that as proof that you attended, and we will process those once we receive the form that you submit.
Great. Thank you so much, Maheen. I hope that answers your and Keshav's question. Another few questions, Mark, which have sort of come in is around the student profile that you guys are looking at for prospective students who are looking to get an admit into Boston University. What is a typical student profile, or what can students do to ensure that it really stand out and make the cut?
Yeah, it's a great question. And obviously, everyone wants to know, what do I need to do to get in, right?
Yeah.
So one thing I will say is the inherent flaw of the question is that there is a typical student. And I think that right there speaks volumes about what the department values. Obviously, we would like students who have a strong foundation in computer science, but we
Mhm.
don't always have students like that. For instance, one of the folks that I actually interacted with recently, he was a music major. So it's not always someone who's studied computer science in depth, but it's someone who has at least the foundations. We obviously want students who will thrive academically. We don't want students that will struggle. So this is where grades will matter a lot. We also understand that not every major is created the same. So we know that some of your programs are much more rigorous than others. We know that some schools are far more rigorous than others. So we will look at you in the context of both your school, your major, and the country at large. So in as much as we do like, really good grades, we love to see A's and B's, as we would say here. We also understand that it's very difficult to pull that off if you're doing a pure math major or an engineering major or something like that. So within that context, obviously, we will look. We also want to make sure that because when I said you don't struggle, there's the perception right from the beginning that our faculty don't need to reteach you the basics, right? Because they're going to jump right in. These are
Right.
short, intense programs. So they want to make sure that they don't need to do as much hand holding. So they're going to look at the specifics, particularly of the higher level courses that students take and how they did. Um, GREs are not required. However, if you submit them, they will definitely look at them. They're trying to gauge typically the math section, like how
Mhm.
technically savvy is this student? Will the math like trip them up? They're also looking at what you've done. What are your interests? Like, who are you? They're reading closely your statements of purpose. So they want to get to know you in that process. They want to make sure that you'll thrive, but they also want to make sure you're going to have a good experience, right?
Right.
So this is where making sure that your aspirations are aligned with the program. Do your research. This is also something that will come up in our application process is what does the student want to do? And are we the best program or the best fit for them in terms of what they want to do and where they see themselves going? So tell your story, share your narrative. This is where you can stand out. You don't have to lie. You don't have to read like, oh, BU really cares about AI. You're like, I really want to study AI. If
Yeah.
you're a cybersecurity person, if you're a different type of data analyst, if you just like the idea of working with big data, and generating ideas of your own and doing your own research that's not necessarily all of the buzzwords, that's
Right.
okay too, right? Like we don't want copies of the same students in our program. We want students who are highly motivated. We want students who are talented, but they're going to be differently talented and differently motivated, and that's okay. I think that's what makes our faculty actually more
Yeah.
excited, is dealing with students that are coming from different backgrounds and doing different things. So just be yourself in this
Yeah.
process.
Great. So, Mark, as they say, to apply to be you, be yourself.
Yep. Yes, indeed.
That is one way of putting it. Great. I hope that answers quite a few of your questions, Iman, and a few of you who had asked these, Aditya, as well. Great. My next question is from Malik, who wants to know, how do students sort of apply for graduate assistantships or TA-ships once, let's say, just before they're getting onto campus or once they are
Mhm.
on campus?
Yeah, so the way it works here, we actually require students to be here to apply for those. The
Yeah.
reason is typically the easiest way is for a faculty member to get to know you in their classroom. So typically after the first semester, you've proven your worth, right? You've proven that you can handle the work. We don't blindly assign TA positions because we want to make sure that you're actually qualified. Imagine if you're
Mhm.
a student and the person who's your TA got a C in the class, right? So we want to avoid that. We also want to make sure that you know all of the opportunities that are available to you so that you're applying to the right TA positions.
Right.
Typically, what ends up happening, students get to know the faculty member or they get to see what opportunities are available in the department. You can also apply for these positions outside of the department. So, this is another reason why we like for our students to actually be here within their first semester, is typically when students will start thinking of applying. And the better you do in a class, the more likely the professor might actually approach you and say, hey, would you like to be my TA next semester or next year to
Right.
teach this class? So we want to get to know the student before those opportunities are extended to them.
Great. There is another question from Isha, but I'm going to sort of generalize it. Let's say, for example, a student is studying in a particular domain, but they have an inclination towards doing a master's in another domain. It
Mhm.
could be in a related field. Is that something that BU encourages students to apply to for their master's?
Yeah, I think one of the things that really sets the US education system apart is the flexibility, and that's sort of
Right.
baked into the program, even at the master's level. So, obviously, if your undergraduate major was music and you're like, I really want to do literary translation, that may not be the best
Yeah.
alignment of your skill set with what we have to offer. But we have seen students, for instance, think that they want to do something within computer science and then realize that their interest is a little different. So
Right.
data-centric computing, for instance, someone might find out what that is after they've started the master's. They may have started as an artificial intelligence student. They can switch, they can talk to their advisor and
Yeah.
do that. We've also seen for some of our more expansive programs, students who've studied math who then end up doing statistical practice,
Mhm.
which is more of an applied ability to look at statistics. We've seen students who have studied psychology that have gone into economics, where
Right.
they have looked at consumer behavior and consumer pricing and things of that nature. So there is a high level of flexibility. I will say the caveat is within reason. So it has to be at least something that you're not playing catch up with your other
Right.
colleagues who may have studied that as a major.
Great. I hope that answers quite Isha and a few others who had asked a similar question. The next question that I'm going to take up, Mark, we keep hearing about this one, especially from the students in India, is someone who has a 3-year bachelor degree eligible to
Mhm.
apply to the programs offered in Boston?
Yes. So our short answer is yes, they are eligible. Um, and I know the system has changed, the rating system has changed. We typically see students applying from A-star universities with a 3-year, and we will value that as a 4-year equivalent.
Okay.
If your university is not one of those universities that's listed, we'll still look at the transcript and look at the specific classes, and it's a case-by-case basis at that point. But we will absolutely admit students with a 3-year degree. Obviously, if you have that 4th year and you did really well, it may bump up how we perceive you. It may increase your ability to get additional scholarship, that sort of thing. So there are implications with the 3-year degree, but that's not to say that we don't award scholarships to students with the 3-year degree. It's just we have more points of contact, we have more info if you've
Right.
been in a 3+1 program.
Thank you. Thank you so much, Mark. I know we've hit the time mark as such. So I'm just going to take up my last question for today. And I'm going to generalize this because there are quite a few questions which are still there. Can you speak a little bit about the student life at the UCAS? Leadership opportunities, internship opportunities. What can students, especially international students who might be going abroad for the very first time, expect once they come onto campus?
Yeah, it is a great question. And I think it's so hard because you don't know what you don't know until you're
Yes.
literally boots on the ground here and you're like, wow, they said it was cold, but this is cold. Or for instance, like navigating housing. What I will say is there's a lot of support that's built in. We're not going to let you blindly navigate this process on your own, particularly if you've never studied abroad or you've never done an exchange program or something like that. Internships are readily available. Some departments will help with the internships. Our Center for Career Development does a wonderful job of helping as well. There are companies that come on campus that will recruit students. There are companies in Boston that we have pre-existing relationships with. For instance, I
Right.
mentioned our MSSP program, Statistical Practice. Part of the curriculum is actually within the first semester, you're doing actual problem solving for companies. Our students are working in one of 4 groups as a cohort. Those companies include State Street, Fidelity. Some of them are healthcare related. So you're making inroads, you're making links within the industry. Our alumni are also actively engaged. Many of the departments actually have weekly programs where they bring back alum to talk about their career path and things that students should take into account. Summer internships are also something that students should start thinking about earlier rather than
Right.
later. So this is where the departments can help. You will also be introduced we have communities that are built in. So once you're an admitted student, we offer you the opportunity to connect with students that may be from your region. They may be studying your subject, for instance. As you can see, I liked Brian's like thanks to my co-authors because you could see the diversity of where
Right.
people are coming
Yes.
from as well. You're going to be meeting a lot of people. You're going to be engaging. Just pay attention to your email. Even though it's antiquated, we still use email as the primary source of contact, but attend the information sessions, attend the admitted student sessions, get to know the students, ask your questions. No question is too silly, especially when you're trying to navigate a visa process that isn't always the friendliest for international students that may be unfamiliar with it. So we're here to help you walk through all of those steps. Um, this is a very dynamic city. There are many students. There are 250,000 students that come into Boston every
Wow.
fall, which doesn't sound like a lot in India, but when you consider the size of Boston is a lot.
True.
That's like a significant population increase. So there are going to be a lot of students just like you. There are a lot of resources available as well. So it's not just what you're doing in the classroom. but outside of the classroom, access to the arts, discounted tickets for concerts, sporting events. Like these are things that I think really help encapsulate what a US experience is. It's not just
Right.
living here and going to class and learning from faculty. It's going to interesting restaurants. It's meeting new people. It's understanding the crazy Boston sports culture. It's also traveling within the states because New York is, depending on how you go, I fly now because traffic can be horrible. It's a 37-minute flight to get to New York from Boston. So that's something that students can think about as well. We see a lot of students who do summer internships in other states too. So ample opportunities. This is a college town, but when we say that, it's like the epitome of a college town.
Thank you. Thank you so much, Mark.
My
I'm sure that
pleasure.
answers all of your questions. In case if there's anything more, feel free to reach out to us at Seed Global Education and we will be able to help you. With that, I would like to thank, we still have around close to 120 of you stuck around till the end. Thank you so much for helping and being there. Thank you so much, Mark, for your time and for this wonderful session. And we wish you happy holidays and look forward to connecting with you soon.
Thank you all. And I put my email address in the chat for
Great.
any questions that went unanswered. Feel free to shoot me an email. Let me know that you attended the session, and I'm happy to continue the conversation where we leave off. Thank you for
Thank
being
you.
an awesome host, Sabahat.
Thank you so much, Mark. Have a great evening, everyone. Bye bye. See you.
Night all.
Bye.